see you again. We used a lecture on Wednesday. DIFO some non-foreseen consequences. And extended consequences. And we shall usually probably agree to find a suitable term to make an assumption. Then the future, but the nature of the lecture might be at any place, at any time, you know, because it does not affect a lot, maybe a little bit the project, you know, how you're going to approach it, all the aspects of the concept, but it can come almost to the end without any other problems. During the first lecture, we discussed a little bit about the particulars of the course, the objectives, the learning outcomes, and what are the necessary requirements to be fulfilled, you know, from academic point of view in order for you to pass the course or successfully complete the course. In addition, we started with discussing what is digital forensics, what is cyber forensics, why is it important, that it's a multidisciplinary area, that sometimes, actually many times, there's an advantage, but sometimes, since it's fairly young, it still tries to build and to develop concepts, ideas. Something which is called theory, something which is called educational practice, something which is called practice of the profession. So something that reflects that it's what is the sort of the concern of the profession or whatever. Well, it starts that it's of durable human interest, and evidently we were able, I think, to establish why this scientific discipline and subject area that we have selected also follow this term, which the first part of the term is of durable human interest, or it's a durable interest of the society. We also discussed all the relevant parts, you know, how it touches upon security, or it's a part of the security, how there are some areas in security like auditing and everything which look very close, and what are the salient or important differences to call this a science of computer or digital forensics, and to call the other one the science of auditing or accounting or monitoring and control, whatever you would like to call it. We continued with discussing a little bit how it comes. You know, somehow it was very interesting to see the time continuum or the timeline, and basically a parallel development, two parallel portfolios, the portfolio of computer and communication technology or information and communication technology development for the last 78 years, and also at the same time the abuse or the misuse of this technology, first, as we shall see, as a tool or as a subject to do certain things, and second of all, to be an object of our concern which relates to unwanted activities in the cyberspace or on the internet or around our computers. We said we're going to be primarily concerned with digital forensics, that's why we are here, and we try to identify the importance of ICT or information communication technology by defining different domains. Actually, these domains actually, in a way, define where we can look for certain things that might be, in a way, usable, might be of concern, and might be important, you know, or has important consequences with respect to our digital forensic investigation. And as you remember, I think that you should have a lecture now in iLearn. I'm a little bit behind, not with the lectures, but with placing them in the right place. But I think that they should be there today, all of the lectures of the first part, and actually we continued with basically defining what are the necessary components of this ICT or ICT technology, the hardware, the software, the networks, the special entities, and what are the relevant, because these entities or devices and software will play a major role in our digital investigation. That's where we look for, that's what we would like to seize, retain them, and preserve them, where the evidence is, basically everything that has the capability to store any kind of digital evidence, being that a live memory for the duration of being connected to a power, or whether it be in some kind of archive storage like this, like USB dongles, part of the working storage like read-only memory, or maybe programmable parts of this memory. Just go over them. You have usually I put much more than I talk about. I'm here to underline, to select the most important things. But anyhow, I would like to take care that somehow the lectures are complete, and even things that we have talked about, or even things that you should know about information and communication technology, like the architecture, the organization, and everything will be put there. So in order to help you learn in a much easier and in a better manner, in a more complete manner. So I will not go, what is a hard disk, what are the components and everything. I put the most important things, the most relevant stuff, at least in my humble opinion, and then just go over that and so on. Look at some new things, that you already are familiar with, for example, SSD memory and so on, and especially the live memory and the difference in the technology of live memory, because it sometimes plays a significant role, which means that we usually, with the tools, have to play occasionally at the catch-up game, but that's not surprising. But also look at, for example, why sometimes erasing data or digital evidence from a USB dongle or SSD memory or something like that might be not so trivial. You might have 30, 40, 60 runs. On the other hand, you are aware that the life cycle of SSD memory is limited, and basically, for example, it's strongly advised that you don't do, it does not really affect, but even if it does affect, you don't do too many defragmentation on the SSD memory, because every defragmentation includes writing, and as you know, writing is one of the black spots or bête noire of SSD memory, because the life cycle includes so many writes. It's still a fairly large number, but if something used to be is going to be used for a probative stuff and everything, you would like sort of over a longer time continuum to preserve this kind of evidence. So let us look at briefly. So this was just a brief recap, but a reminder also to just make a short survey of 7 or 8 slides, which are elementary, but deal with this kind of stuff. What are the key concepts and principles we will discuss? We mentioned, in order to get the evidence, for example, and I would sometimes refer to crimes. I usually would like to refer what I call the unwanted or undesired activities in the cyberspace, not only crimes, but any kind of undesired activity or unproper. And of course, you have to first sort of identify this evidence. But once you identify that it's important, or actually I'm making some kind of unintended error, and this is calling it evidence, we still don't know. But potentially some kind of a digital data or whatever is going to become evidence. It's we shall see later. It's a matter of judgment, it's a matter of scrutiny, and so on. So we are interested in deriving our actually sizing our devices and our parts of the software, if possible, including the things that have been memorized and stored, especially with respect to data and metadata. And metadata, if you have followed the Snowden affair, which is fairly recent, for the last 5-6 months, you will probably notice this kind of a semantic game that they play with between the data and metadata. You already know what is a metadata, probably. Meta is something beyond. There's the reason that, for example, if you go to natural sciences, you talk about physics or a reality, and then you call about metaphysics or something beyond reality. Not that it means it's imaginary, but something you don't see apparently right away, or something to discuss, like in mathematics. In mathematics, you have a proof of Fermat theorem, for example, a proof of, I don't know, the derivation law of Newton or whatever, the first derivative, the second, and so on. What will be a meta-mathematics? Well, meta-mathematics is not concerned so much about a theorem in a specific domain, that's the reality, but it's much more concerned about what is really a theorem, what is really an assumption, what is a hypothesis. So all these terms that we take for granted in a way, in a reality, talking about mathematical hypothesis or hypothesis fixes and everything, they start with. So actually, in a way that says that, if I have a Fermat theorem or whatever, or theorem of maximum meaning or whatever in mathematics, or the Lagrange theorem, I'm talking about this kind of elementary stuff or elementary problem. Then in mathematics, when you go one step behind the reality, and here is the theorem. It has certain things, For example, the Fermat theorem says that there's a place where you have some kind of a maximum meaning, the first derivative should be equal to 0, and that's fine, But then you discuss, as I said, what is a theorem? So actually you go beyond. So basically, in order to be able to understand what theorem is and that kind of stuff, you should look at the meta level and so on. So it says you, so here I just trying to one thing, that metadata tells you something about the data. And that's the reason now they are playing, National Security Agency or NSA was not looking at real data, so your name or your birth date or the number of days that you have or something like that, but was looking at the metadata that says, well, number or birthday place, that will be a metadata, or birthday or whatever, this kind of attributes or this kind of categories. It's just a game of semantics, And sometimes metadata tells you the whole story. So data, you go one step, it's a data about data, very simply, and explains the data. You ask yourself, of course, and that's very important, especially if you like to make things probably, to stamp the court of law and so on, that's whether when you have a seizure of certain things, size them and actually later on try to preserve them, because as you shall see, they are part of the chain of custody, how these are sort of stewarded and shepherded in a way, in this case the data, which can be used later for analysis. Then you ask first whether you have done it in a lawful way, because you're there to prove certain things, and to execute the law, for example, to show this kind of unwanted, undesirable activities, but also it's so the first thing, as I said, it's almost axiomatic. You said, have you followed the letter of law? So that means that whether it depends on the law, whether it's common law, or president's law, or constitutional law, depends on the country. There are also international, national, regional laws, or whatever. There are things that, for example, in many states for a common law, but I think that almost in every country, in every country that has a democratic provenience, and democratic flavor, there should be some kind of involvement of courts in the whole process, So there should be what they call it a warrant, issued by somebody, usually the judge, investigating judge, a district attorney, and so on the demand of district attorney that you can go and take the evidence. So it has to be lawful, it has to stay the law. But also there is something stronger than the law we should see in a moment, when you look at this kind of a superset of different activities, there is something which is always, law is about reality and that kind of stuff, but which is higher than the law, and this is something which is, whether it's ethical or not, whether it reflects some positive and good features in human relations, or it does not have. So those are the two concerns mainly that when we take evidence, whether has been done. Sometimes it can follow the law. If all the law was ethical, because evidently the first one is in a way a superset of the other one. It's basically, it will be a wonderful world, but it's not. And many times you have heard the saying that law is not about the justice. And justice is probably much more important, than even today freedom, because many countries are free, but they don't have elementary justice. But this goes also to the ethics of the society, which we don't have time to discuss. The second step, once you identify and seize and say, well, this computer is taken according to certain principles, law principles, or laws, or whatever, and you have hopefully preserved the ethical consideration of the party that is the computer, then actually you're talking about acquiring. And bear in mind that I'm trying to introduce the model slowly to infuse the model of digital investigation. Because there are different models. We cannot do without models, even in digital forensics. On the contrary, sometimes there are too many. So the second thing is to think about how you can apply this evidence. It's one thing that you see the computer mind to transfer it, or identify it in the computer or in the hard disk and everything, whether everything is okay or not. And done in a proper way. Once you acquire the requirement of the preservation of the evidence is important because it's the basis for our analysis. And as we said before, after the analysis comes reporting. Reporting can be usually, there should be a written report. And I think that our little helpers in the lab, our good stuff in the lab will probably provide you with a template of a report, which should be, in a way, should represent this kind of a forensic stuff. And I think this template actually should help you follow and not forget certain steps from the procedure and certain phase of this digital investigation. And in the end, as I said, in addition to this kind of templates reporting, which actually put the results of your analysis, you put conclusions, but not conclusions about the case, if it's about some crime or something which is unwanted, but conclusions based on just the facts that you have. So there is no any kind of interpretation. Because then comes actually the law and that kind of stuff, and they interpret things, and that's where, because many people can interpret things in many different ways. Different people interpret certain things. And that's the reason we're trying to make models, even of the reality, in order to be able to have as much as possible unique interpretation, which is, when human beings are concerned, very difficult. And that's why sometimes law is not considered, even they talk about the science of law, but how much is science with respect to mathematics, physics, chemistry, or astrophysics, or whatever, it's another question. Okay. So reporting can be also verbal. You can give a testimony in the court as an expert witness, something like that. You can take other forms, super analysis or review analysis, something like synthesis, and that kind of stuff. Okay. So this does not work again. Or maybe it's gone asleep. Okay? What are the other? Safeguarding. And I had not formally defined it, but I thought that this is what stewardship or guarding or preserving the evidence, And you should see that it's very important all the way. And then, of course, not all the information, you see, you can make many classifications. You can find many categories, depends on the methodology also. But basically, the most important thing is that Some evidence will help you uncover other evidence, but maybe it not be just a point that one could have. But some evidence, and that's what we call a notable evidence, something that you definitely should take a note of. But other evidence, information actually, where I'm talking, that has a value for us, it's what is called real evidence or evidentiary information. And finally, another concept, a key concept, is critical, and it's interconnected with the other concept of probative value, that stands the court of law, evidence, etc. And that's actually that you're looking for an evidence that can stand the trial of fact, or actually some kind of withstand the scrutiny, any kind of examination. We shall talk about the problem of making our evidence scientific evidence, and making our analysis scientific evidence because, as you know, there are two types of events in the world around us. And those two types are evidence, not evidence, events. I'm sorry, events, an event. Do you know what are the two types of two different kinds of evidence? Oh, the events, I'm sorry. Too much evidence around. Because we'd like to connect to the trial of fact. Well, let's make a long story short and say that, first of all, there are events that you can reproduce, and something that we would like to do, if possible, in the area of science, of any science. If you have something that you observe, you made certain conclusions, and anytime you say, well, wait a minute. Maybe it's not what you are saying. It's not correct. Then we should try it again and that kind of stuff. So maybe you can reproduce it, and that's what we're trying to do in the labs and everything to reproduce. We have reproducibility in computer science. Our many things that we do in computer science, the programs are every program is an experiment. So you run the program for one input, then run for another one, for third one, and everything you check. It's important also when you have an event and you try to reproduce it to find the bounds of the possible results that might, or possible outcomes. So we try to test it in an extreme condition, conditions when you require, for example, some kind of a maximum of your data and some kind of a minimum of your data. But there are also events that cannot be reproduced. For example, that's the reason it's very difficult. One of the events, let's forget about digital forensics, let's go to the real classical forensics. In order to be able to show that somebody is a murderer or whatever, you don't commit murder again, to be able to explain in the court and say, well, let's try to do it in blood. There is something which is called, I don't know, the French Revolution, the English Revolution, the Cromwell, and that kind of stuff. That's why sometimes sociology, history, and everything is questionable from a point of view of natural sciences, because you cannot say in the lab, well, we have some time this morning to reproduce the French Revolution. Okay, today we have a lot of computational communication power, so we help these things, produce them in a way through simulation, or at least simulate. But simulation is a reflection of the reality, it's never a reality. So that's different. But if I have some lab, in chemistry and everything, if I have a couple of compounds, I can reproduce the things in a proper way without provided. And then when you say, well, reproducing the event, it's very important to reproduce it under the same conditions. So usually in physics, it's the pressure, the temperature, the humidity, the vacuum if you're doing with something like that. Okay? And this should indicate why it's not so trivial, to actually repeat or actually to prove that some events have happened, and they have happened in the way we try to explain them and to make them probative. So, omnipresence and abundance of this evidence, that's clear, we discuss it everywhere. And all of these are basically a sort of an objects of our interest. Hard disks, dongles, optical disks, GPS navigation units, smart cards, digital paper, clothes, and it's becoming, more and more, especially now digital paper is becoming. Now with interesting these three-dimensional printers and so on, you might be able then to not only talk about the digital evidence, but also sort of having a real artifacts behind that. So it's not only digital artifacts concerning data and metadata, but only real objects and so on. One of the big problems we said is that systems produce a lot of large volumes of data, which is a challenge with respect to security, but even more to investigate this data and so on. You can talk about terabytes of data. What is good is that this system that produce a lot of data, like clouds, for example, data centers and everything, can be also used, as I mentioned before, to analyze this data and so on. So you have a sort of a, occasionally it might be a vicious circle principle, but it's not. It's sort of, actually you can look at the things like on a meta and real level. So that this evidence is in the real, produced by the cloud, but then you can use the cloud to sort of boost your computational power and communication power in order to be able to investigate the nature of this data. Why? Just a part of something which said Richard Rubin about 7 or 8 years ago. Why is digital world so tempting? You know much more because you're part of the digital generation, much more than I do. But some of them say it's actually something like speed. You're concerned about your privacy, anonymity. Nobody knows the old sentence about the internet that nobody knows whether you're a dog or a human person behind an email, allegedly, but not according to the NSA or so, or something like that. The nature of the medium, which is in a way persistent, but yet it might be destroyed. It exists, but basically it does not exist. It's just a collection of 0 and 1. Of course, on some physical level or whatever, these are kind of different voltages, different currents, and so on, induce different states. A state of high energy, for example, depends on the logic that you are using, that has 1, and the state of low energy that has 0, and vice versa. Attraction, many things aesthetic, that you can actually do with this. Some of them are very nice. You remember the story about Stephen Jobs. What is interesting for those that are sort of immersed in unwanted or undesired activities is the number of people we can reach. So that's very positive. We talked about social networks and everything, but this is also every member of a social network is a potentially your victim if you are interested in this kind of unwanted activity. And the old saying that when you have the computers, when you have the communication, when you have your powerful hardware and software, interconnected and everything, internet does not recognize any kind of borders, which I think I mentioned before. It also poses some even legal problems, not only sort of semantic problems with respect to the value of the information. And I don't know why he put it, maybe, but being able to reach so many people and actually to influence even the state of the society, again, I'm referring to social networks and everything, maybe gives you or maybe to be able to destroy a whole system, to steal thousands of numbers that relate to credit cards, or to mess up a lot of passwords, it gives you some kind of a power, Having some kind of a power is probably inherent in the human beings who would like to think about themselves, each one of them being unique in some way. Okay. What is an evidence? We talked so much about the evidence and so on. Why it's important, we mentioned. You can go take a look on the web. There are many definitions, many discussions, some of them many classifications, different type of evidence. Sometimes this kind of categorization, classification, it's not quite. They don't use the same criteria, so occasionally I feel that they compare apples and oranges, but it doesn't really matter. For type of evidence, we are talking about intuitive, so basically you cannot prove it, but you feel might be important, and might describe might be relevant to a certain event. That take the event as a key, something that we would like to describe, you know. Might be a sequence of events, you know, aggregation, doesn't really matter. Linear combination of events, non-linear, doesn't really matter, but the evidence with respect to event might be intuitive, so there is also even a formal system people invented called intuitive logic, you know, because they say, well, there is nothing, there is no real formality, there is only intuition. And this is actually, you know, sort of I would say, a permanent, sometimes hostile discourse between two different groups, you know, between the group that's saying, well, everything can be proved is relevant to reality, and the other group is saying, well, no, there are many things which are intuitive. But intuition, what is good is that the intuition sometimes can help you select from a lot of data something which is relevant, might lead you, but that will be not enough. That's what we call a hint, you know. That will be not enough to make your evidence saying, well, I just feel that this person, I don't know, produced some kind of a botnet that, I don't know, stole so many words or destroyed so many computers, made them dysfunctional, and so on. So you have to go beyond scientific, and that's on the top, sort of the Olymp of our evidence, you may say so, you know, which means that it's provable and it's beyond any kind of doubt, or what we call reasonable doubt. I mean, it's something, this is white, this is white. You know, okay, the lawyer might say it's black, no, or argue it's gray, but it's just beyond, when we say science, science is here, it's something between the truth and intuitive and maybe personal and anecdotal will be in the realm of belief, you know. And the only difference between the two reasoning systems, or system of inference, is that in the first case, in the case of scientific, the axiom of truth holds. In the other one, it's not necessary. If I believe something, that doesn't necessarily mean it should reflect the truth around me, or the truth in general. There is a personal, as I said, what we call it sometimes subjective. It might be, because I might give it my personal, my own twist to this, you know, anecdotal, you know, you heard something about something, and you just tell it to a third person, there was some occasion, some event, and the road that happened, and so on. There is legal, and we would like, legal will also connect. There will be a lot of illegal evidence, but what will make it really legal will be if we can draw an equivalence between, or some kind of a if and only if relation between scientific and legal. Of course, you're going to use anecdotal evidence, personal evidence. You know, that's the reason people are involved in unwanted activities, you know, or illegal activities will give a testimonial. But basically what we are looking is that our evidence is scientific. I made some kind of a division. This is a fairly old idea, but we discussed about ethical, legal, and that kind of stuff, approved activities, and here we are talking also, when we talk about ethical, we are talking about also taboos, you know, something might be according to law and everything, but there are many communities, very large, many regions, and that kind of stuff, that live by this kind of use unwritten laws that have been taken from sometimes, some of them, you know, have been written, but otherwise they are taken orally from one generation to another, and they become a taboo and something, a territory that you don't know actually, this kind of territory. And something which we call, I was very generous actually, saying that these are generative activities, sometimes might be unwanted, sometimes might be wanted, and of course, I hope eventually one day they become legal activities, but they are very creative, you know, they are very creative, even crimes are creative sometimes, unwanted activities, you know? Although they hurt people, they hurt property, damage property actually, and so on. Computer crime, I'm just, you know, that our goal is attributed with helping develop internet knowledge and making some decisions, you know, and he did. At the end of the last century and so on. But But it's not blaming, you know, because crime is a crime. Unwanted activity is unwanted, you know, that we would like to investigate and so on. And actually, just things are becoming more apparent. Maybe the volume has become, you know, larger, especially since the subset of, or the set actually, of unwanted activities has become much larger. As I said, the computer, as we shall see, might be an object and subject of a crime. So that's the reason I'm saying new types of crimes, for example, hacking or denial of service, something that was not known so much before, you know, because this kind of, because we have become a digital service society. I usually say everything is a service and service is everything, and referring to this kind of e-services. Imagine your world now that we so much depend on this kind of so I already implicitly, in a way, defined 3 different types of crime, but using computers, of course, because we are talking about computer right now. And this is a computer as targets, basically computer as objects are under the attack, you know, so they're object with respect to all these things that we would like to have: privacy, security, anonymity, and so forth. All the salient attributes of security, something confidential, they preserve the integrity of the data, to have your systems, if you have a denial of service is nothing else. There's the reason sometimes actually is not even classified as a security program in distributed denial, although it has a security implications because basically it's somebody depriving you of all the computational and communication resources that you are entitled to. Basically, it's exhausting the resource allocation pool in a way which is not useful, usable, and productive. Which actually deals with accessibility and availability of these devices and so on. So this is something which we call enactive, because in that case, usually some of the evidence even dynamically changes, let alone including the networks. Actually, the data is in transition. Computers as a sort of data repository. This is a hard disk, optical disk, different types of devices where you store your data, and then you know that your data is stored, safely guarded, and so on. And we call it a passive, so opposite to the other one. And then finally, computer is a tool for committing a crime, and I usually say, don't take the computer as a physical device in this case. I'm not referring to that, because although it's full with digital evidence and it's a digital device, in a sense that taking the computer and hitting somebody with the computer, you know, like this kind of everything. So computer as a tool for committing crime, you know, does not refer to this type of a crime, obviously. So 1 and 2 are the object, where the computer is an object, or anything in the cyberspace that constitutes cyberspace. So your devices, hardware, your software, your records, and that kind of stuff. And the second one is where the computer is actually a subject, you know, to complete another type of crime. For example, to store a lot of data which is illegal, like pedophilia, like human trafficking, and whatever, make you easier follow these people that eventually you want to hurt. So that it's an object, or using your computer or using the computers which are part of a network, you know, to attack another network or another network and so on. This is actually when the computer is the device. Okay. Some forensic elements, because we are not we are interested also, we are talking about computer and digital forensics, about the evidence, and we will not be limited only to digital evidence. After all, since the computer, this is a real artifact, a real object, so on. So the evidence might be that we should go physical, that we have a computer, we have a disk, we have a demo, we have a network device, we have a bridge, we have a router, and so on. And then electronic, digital, in electronic form, which is produced or generated by that device. what are the stakeholders? Because the first thing you ask, you're going to be a lot of data. What we said, a notable data and evidentiary data and everything. There will be a data which will be basically a junk, not usable, garbage, that kind of stuff. And then what helps you discern, among other things, once you decide that it's who are the stakeholders in the case, who are the relevant involved parties, actually that makes that gives attribution to your evidence that it's relevant also. So we mentioned who are the general stakeholders. We talk about governments, national, international organizations, military, police, whatever, corporations, and so on, everyone basically, because this is a sort of effect of life, and law enforcement agencies, this is obviously. And what is important also is once you decide, this thing is contains evidence which is relevant, which has to be seized and then it has to be preserved and it has to be analyzed, then you start discussing, well, fine, we said this might be relevant, or it is relevant, now we discuss how valid it is. Is it acceptable or not? Whether we can sort of infer the correct attribution and the correct sources of this. Thank you so very much. I will continue in about 10 minutes.